Okay, so before the break, we were getting pretty good at being able to identify what kind of reaction was happening and then predict the products. Okay, so I want to kind of review that today. Near the end of class, we'll talk about the lab we're going to be doing tomorrow. Okay, and that way tomorrow we'll do like a short quiz and then we'll do the pre-lab stuff and get into the lab. Okay, and that way we'll have lots of time to get everything done. So we'll kind of talk about all that stuff today as well. All right, so what I would like you guys to do is to have you just write down, let's say, the first two here. Okay, I'll give you a couple minutes to get those written down, and then we'll walk through them together as a bit of a review, and then I'll have you try a few of them on your own for predicting the products. Okay, so just get what's up here for right now written down, and then we'll talk about what we do. All right, so if we're going to predict the products of a chemical reaction, what's the first thing we have to do?
Identify the type of reaction.
Exactly. I got to identify the type of reaction so that once I know what type of reaction is happening, I can use the pattern for that reaction to figure out who goes with who on the other side. All right. For our first one, I've got a carbon-hydrogen containing compound reacting with oxygen. What's the only reaction type that starts that way? Combustion reaction. Okay, so now that I've identified that it's a combustion reaction, okay, I can use the pattern to figure out what the products are. Luckily for combustion reactions, that's just a matter of memorizing that the products are always what two things? Carbon dioxide and water. Okay, so now I've got my products. Okay. In this case, there are no special elements that are produced. There's no ionic compounds that I need to check for drops and swaps. It's good. All right. What's the last step? Balance the reaction. Okay. In a combustion reaction, two special balancing rules. Do I need them both? Yes, I need the rule of two as well as balancing alphabetically. So I'm going to start with a 2 because 8's an even number. 2 times 8 is 16. Okay, 2 times 18 is 36, and 18 times 2 is 36. And now I got to figure out how many oxygens I've got. So I've got 32 oxygens here. 16 times 2 is 32, plus 18 more is 50. All right, so I've got 50 oxygens in total on the product side. What times 2 will give me 50 over here? 25. Okay. If you arrived at school today in an internal combustion engine powered car, that's one that takes gas. That is the reaction that got you here. Okay. C8H18 is octane. It is the stuff that is in gasoline. Right? If you've ever filled up your car, okay, there's like regular, mid-grade, and premium, and the numbers on them, 87, 89, and 91, are the amount of octane that is in the fuel. If it's premium, there's more octane in the fuel and it burns hotter, okay, and produces more power. All right, now, don't just think that, ooh, my car, more power, I'll just put in premium. No, okay, your car is designed to run on a certain type of gasoline. If your car does not take premium, don't put premium in it. Making it run hotter can damage some of the emission control systems, and then that's an expensive fix, and you don't want that. Okay? Similarly, if your car is supposed to take premium, don't fill it with regular. Okay? Same thing will happen. Okay? So you gotta make sure you put the right kind of fuel in there. Okay, in reaction number 2, I've got sodium phosphate, which is an ionic compound, reacting with lithium oxide, which is also an ionic compound. What kind of reaction am I looking at there?
Double replacement.
Double replacement reaction. Okay, in a double replacement reaction, what's the pattern? What's going to happen in a double replacement reaction?
Metals swap.
Metals swap. All right, so that's going to mean then that sodium is going to end up with oxygen and lithium is going to end up with phosphate. Does it matter if I write NaO second or first? It doesn't matter. All right. I just made 2 ionic compounds. What do I need to do with both of them? I got to drop and swap. They're ionic compounds. Okay, so this is a -2. That's a +1, so that's going to mean Na2O. Lithium's a +1, and phosphate's a -3, so that's going to be Li3PO4. Okay, and now I got a balance. So, 3 is my biggest number. It's for sodium and lithium, so since sodium's first, I'm going to go with that. 3 sodium on this side, 2 over there. What do I need to balance it with? 6, yeah, okay, so 2 times 3 is 6, and 3 times 2 is 6. Now that gives me how many phosphates?
8.
Well, it gives me 8 oxygens. How many phosphates does it give me? 2, right. On this side, I only have 1 phosphate, so it needs to go here. 2. All right, when I do that, that gives me 6 lithium. So if I go back over here, okay, and put a 3 there, that gives me 6 lithium and 3 oxygens on both sides, 2 phosphates on both sides. I think I'm good. Okay, everybody all right with that? Okay, is that ringing a bell? Okay. Okay, let's have you guys try the next 4 here. I'll give you a little bit of time to get ahead of me. Okay, so for number 3, I've got phosphorus reacting with calcium nitride. What kind of reaction am I looking at? Single replacement. Yeah, I've got an element reacting with an ionic compound. So, in a single replacement reaction, which is the type that has the most things to think about, phosphorus is a non-metal, so what part of calcium nitride is it going to replace? The nitrogen. It's got to replace the part it's like. All right, so that means then that nitrogen is going to end up by itself, and calcium and phosphorus are going to wind up together. Okay, now here's one of the things we have to think about in a single replacement reaction. I'm going to produce an element, and it could be special. Is it? In this case? Yes, nitrogen always comes as a 2 when it's by itself, so that's something I've got to consider, right? And then I'm always going to produce an ionic compound as well that's going to need to be dropped and swapped. Okay, in this case here, Ca3P2. Okay, so I've got that dropped and swapped. Now I just need to balance the whole reaction. Nitrogen, calcium both look good, but phosphorus is out. There's 4 on this side and only 2 over there. So a 2 here will balance my phosphorus, but I'm going to need to put a 2 here and a 2 there to make up for it. Okay. Questions on that one? Okay. How many people have done number 4? Okay, so we'll look at number 4 as well then. Okay, so on number 4, I've got chlorine reacting with potassium. What kind of reaction is that? It's a synthesis reaction. Okay, what kind of compound am I going to make? I'm going to make an ionic compound. So what needs to come first? Chlorine or potassium? Potassium, yeah. That's the trick with this question. If you recall, before the break, I said, I only have so many tricks in the bag, and this is one of them. I give you a synthesis reaction. I put the non-metal first, which is totally fine, but when these things get to form a new compound, they form an ionic compound, and the metal has to come first in an ionic compound. A lot of people make that mistake because they just don't think about it when they put it together, right? This is a -1, that's a +1, so that compound is KCl, 1 to 1, and that would mean that I need a 2 and a 2. Okay. All right, I'm going to give you a few more minutes to get 5 and 6 done, and then we'll have a look at those. And then I've got some that go, I give you the reactants in words, which is about as tricky as they get. Okay, let's look at 5 and 6 here. So for number 5, I've got disulfur trioxide as the only reactant. Okay, so what's the only reaction type that has only one reactant? Other way, opposite. Simple decomposition. All right, in a simple decomposition, this is just going to break down into its two elements. Something I always have to watch for with a decomposition reaction is, does it decompose into special elements? Okay, in this case, one very special element and one kind of special element. Okay, sulfur always comes as an 8, oxygen always as a 2. Okay, how important is it for me to remember that if I'm doing this reaction on a test? Really important, because if I don't get those two numbers right, I'm not going to balance it right, and I'm going to get a lot of it wrong. Okay, and I don't want to do that. All right, so now I've got to balance this whole thing here. So 8's our biggest number, so a 4 here gives me 8 sulfur on both sides, but it gives me 12 oxygen, so I would need a 6 there, and then that would work. Okay. All right, and then for number 6, there's something that comes up in number 6 that's important for us to know how to deal with. I've got copper, which is an element, reacting with an ionic compound, lithium chloride. Now, that's a single replacement reaction. Copper's the metal, so it's going to swap out the metal here, and that means that lithium is going to end up by itself, and now copper is going to end up with chlorine. Now here's my problem. Copper has more than one possible charge. How do I know which one? Well, that's how I would do it if I just was told, here's the name, and then I could work backwards and figure that out. But in this case, they didn't tell me. Like, what was the charge on copper, because copper was an element over here, and I didn't get a word reaction that I could work from here. Okay? So I don't know whether I should use the 1 plus or the 2 plus for copper, because it could end up as CuCl or CuCl2. So which one should I use?
Would you use the first charge listed?
Yes.
If it's not given?
Yep, that's exactly what I do. So if I have no way to figure it out, and in this case I don't, copper was an element which has no charge on the reactant side, then I go with the first charge listed. First one listed is the most common, and it's usually the most common by a significant margin, like we're talking 95% or more. Okay, of copper is going to be the 2 plus. All right, so if they don't tell me, and they don't give me any way to figure it out, which they didn't in this question, then I would say, all right, it's the most common one, 2 plus. Chlorine is a 1 minus. And I'm going to have CuCl2. So it's not something I don't think that we've done, or maybe we covered it, but it would have been before the break. It's something that comes up. That's how we deal with it. Okay, now I got to balance this whole thing. Copper's the only thing out of balance. So chlorine's the only thing out of balance. 2 and a 2 there should fix that. Okay, just making some sense? All right, and we're not going to do this one, but in the next one here, okay, I do run into a metal that has more than one possible charge, but in this case, because it was in a compound, I could do what you were saying, and I could say, well, this is a -2, so that must be a +2, and go from there. But because copper was by itself here, I couldn't do that. Okay, and I needed to know what copper was over here. All right, so that's one of those kind of rare cases. It's usually a single replacement reaction where that comes up. Okay, could also be a synthesis reaction where it could come up. All right. You guys can have about a 3-minute break here while I get the next set of questions up. Okay, guys, I would like you guys to try the first 2 here. So this time I'm giving it to you in words, okay, which again adds that extra level of kind of checks and balances that you have to run through, okay, when you're writing out the reactants in formula form. That's how you start these ones, okay? Then it's the same steps after that. Reaction type, use the pattern to determine the products, check for specials, swap and drop, balance. Okay, let's have a look at these 2 here. So on our first one we have dicarbon, that's 2 carbons, hexahydride, 6 hydrogens, reacts with or burns in oxygen gas, which is O2. Okay, burns kind of gives it away. What kind of reaction is it? Combustion reaction. Okay, so our products are going to be carbon dioxide and water. Okay, do I need both balancing rules? I do. 2 is an even number. Okay, so put a 2 there. 2 times 2 is 4. Now I've got 4 carbons on both sides. 2 times 6 is 12 hydrogens. 6 times 2 is 12 hydrogens over there. And then I've got, for my oxygens, 4 times 2 is 8 oxygens here, plus 6 more is 14. 7 times 2 is 14, and I'm done. Okay, so the added challenge of getting it in word form is that you do have to come up with the reactants formulas on your own. Okay, and there's of course a chance that you mess up a swap and drop or a special element or something like that. Okay, looking at number 2, I've got sodium nitrate. So that's an ionic compound. Okay, sodium's a metal with a +1 charge. Nitrate is a polyatomic ion with a -1 charge. So that compound is already dropped and swapped that way. And it reacts with magnesium. Okay, is magnesium special? It's not. Okay, what kind of reaction am I looking at? Single replacement. I got an ionic compound reacting with an element. Okay, the element happens to be a metal, so it's going to swap out for the metal that's in that compound already, and I'm going to get magnesium with nitrate and sodium by itself. Now I could have written the sodium plus magnesium nitrate, that would have been fine, doesn't matter what order that goes in. Okay, now this is an ionic compound and I have not dropped and swapped it yet. Okay, so I'm going to need a bracket with a 2 outside of the brackets, and then I've got a balance. So 2 nitrates on that side, now there are 2 nitrates on the reactant side, that gives me 2 sodiums. Now there's 2 sodiums on both sides, and the reaction is balanced. Okay, questions on those? Now obviously they become more tricky as I start putting in special elements, Roman numerals, all of those kind of things, okay, in order to make the formulas hard. All right, so let's have you guys try 3 to 6 here. Okay, so on number 3, okay, now that my screw up is fixed, okay, we've got magnesium nitride. So we got an ionic compound that needs to be dropped and swapped. Magnesium's a 2+, nitrogen is a 3-, so we'll have Mg3N2, and it breaks down. So what kind of reaction are we looking at? Decomposition, right? So it's just going to break down into its 2 elements, magnesium, which is not special, and nitrogen, which is. Okay, so now that we've got that, looks like our nitrogens are already balanced, and a 3 here would take care of the magnesium that we had on the other side. Okay. All right, for number 4, we got sodium permanganate. So since sodium is a metal, we're looking at an ionic compound. Permanganate is a polyatomic ion, MnO4, with a -1 charge, so that compound is good the way it's written. Okay, reacts with iron 2 sulfide. Okay, so Fe with a 2+ charge, sulfide with a -2 charge, so that compound is also okay the way it is written. What kind of reaction am I looking at? It's a double replacement reaction. So in a double replacement reaction, we simply swap the metals, so that means then that iron is going to end up with permanganate, and sodium is going to end up with sulfur. Alright, now I just made 2 different ionic compounds, and they both need to be dropped and swapped. Now on this side, the iron was a +2, so on this side, it is also a +2, or is still a +2. Right, and permanganate is a -1, so this is going to require brackets with a 2 outside of the brackets. And then this is a +1 and this is a -2, so we're going to need a 2 there. Okay, and then that means that to balance, we should just require that. Okay? Making sense? Ringing a bell? Okay, how many people have done 5 and 6? Okay. Let's look at 5 and 6, and then we'll talk about what's going to happen here the rest of the unit. Okay, so copper reacts with fluorine gas. All right, copper, Cu, and it reacts with fluorine gas. Is fluorine special? Yeah. All right, what kind of reaction am I looking at? Synthesis reaction. Okay, so they're going to go together, they're going to make an ionic compound, and I run into that problem again. Copper was by itself on the reactant side, and it has more than one possible charge. They didn't tell me which one it is, so I have to assume it's +2, because that's the most common one, the first one listed. All right, and that's a -1, so we're going to have CuF2. Okay, and oh, that's nice because now it's already balanced. That makes it easy. All right, and then for number 6, okay, well, that's no good. Okay. All right, hydrogen sulfate. So we got H, which is a +1. It's acting as a metal because it was listed first, is with sulfate, which is SO4, and is a -2. Okay, so we're going to have H2SO4 when that's dropped and swapped, and it reacts with magnesium hydroxide. Whoop. I did that. The struggle is real today. All right, it reacts with magnesium hydroxide, so Mg with brackets OH, and that's going to require 2 because that's a +2 and that's a -1. All right, so we're looking at a double replacement reaction for that one. We're going to swap the metals. Okay, that means that hydrogen ends up with hydroxide, and magnesium ends up with sulfate. Okay. That's a +1, that's a -1, so that compound is good. That's a +2, that's a -2, so that compound is good the way it's written. Okay, and to balance it, a 2 here should balance both the hydrogen and the hydroxide. Okay. All right, so here's kind of where we're headed going forward. First off, I put your Unit 1 exam date up on the board. Okay, I will also put it in Google Classroom, but it is going to be March 13th. That is 2 weeks from today. Okay, we only have our reactions lab, which we'll do tomorrow, our reactions assignment, okay, which you'll get the whole class on Wednesday to work on, and then we're moving on to mole equation, okay, which we'll do like Friday, Monday, Tuesday, Wednesday. We'll do a unit review, maybe Thursday or Friday of next week, and we're done. Okay, there's really not that much left in this unit. Okay, so we will definitely be ready for March 13th. So make sure you put that one in your phone or whatever you do with important dates. Okay, that's going to be your exam date. If there's things you need help with, pop in and see me. Okay, at any of those help times. Okay, between now and then, that's lots and lots of time. For the unit exam review, what I will do next week is I will post a review package, which contains some practice questions with a key and a practice test with a key. Right? So you can do all the review stuff first and then try the practice test. Okay? And because if you just do the practice test first, all it's going to tell you is you should have done the review package first. Okay? So make sure you do the review package first. And then the practice test, which is very, very similar to the real test, okay, will give you a pretty good idea of how you're going to do. All right. In regards to the lab for tomorrow, so in the lab tomorrow, we're going to be mixing some stuff together, okay, causing some reactions to happen. All of the reactants will be at the front of the room, okay, just like they were the last time. So they'll be on that big teacher's table up at the front. And you will simply take your reactants back to your table and cause the reaction to happen in a little watch glass, okay, which looks like a giant contact lens, okay, made out of glass. Okay, it's just a convex, okay, thing, and you'll cause the reaction to happen in there and record any observations that are important. What are the signs of a chemical reaction, by the way? odor, color change,
Temperature.
temperature change,
Produces a gas.
produces a gas, so bubbling and fizzing, or an odor if we detect that it's just an odor, or both. Okay? And sometimes you make something that's not soluble and it forms starts with P? Precipitate. Okay, so those are the things you're going to want to watch for. So most of those just involve using your senses, but obviously we don't want to have our finger in there to detect temperature changes because that could be bad. So you'll get a thermometer for that, okay, and you'll be able to detect any temperature changes obviously with that. Pretty straightforward lab. Okay, you're going to do a number of different pairs. Okay, so these will be your reactants, okay, and then in the procedure, it gives you the different pairs. So your first pair, okay, or pair number 1 is going to be substance A and substance B. So you're going to be reacting sodium hydroxide, NaOH, with ammonium chloride, NH4Cl. Okay, so it'll be causing that reaction to happen, and then you have to make observations of what occurs. Okay, and then for your second pair, you're going to mix acetic acid. Okay, now, what's the common name for acetic acid? Okay, this is more commonly referred to as vinegar. I'm going to warn you. Vinegar you buy in the store is 5% acetic acid. The stuff I made is 50% acetic acid. So it is considerably stronger. Like if you put it on your fries, it would eat them for you. Okay, like that kind of strong. So just know that, yeah, it says acetic acid, but it's definitely not vinegar. Okay, and you're mixing that with sodium hydrogen carbonate, which is also commonly known as baking soda. You've done this reaction before, so you kind of know what's going to happen there, except that I made the vinegar uber concentrated. Okay, so it'll be a little bit more fun. And then for pair number 3, you're going to mix, again, sodium hydroxide, but this time with magnesium chloride. See what happens. Okay, in pair 4, you're going to mix, again, sodium hydroxide. We use it a lot with F. Now, phenolphthalein is an indicator. It's going to come in a little squeeze bottle. How many people have watched like CSI before? Okay, right. So this is the stuff they use to detect the presence of blood. Right, so if they see a stain somewhere or whatever and they want to know if it's blood or not, they swab it with a Q-tip and then they put a drop of this stuff on the Q-tip. The Q-tip turns pink. It means that there's essentially something there that's the same pH as human blood. Right, so it's how they kind of generally detect human blood. So we'll be using that, okay, because it turns pink in the presence of a base. Again, human blood is slightly basic, so it'll turn, we can get it to turn pink. Now, for pair 5, we're going to take the mixture we get from pair 4, and we're going to add acetic acid. And when we do that, hopefully we'll see something change as a result. Okay? And then pair 6, okay, in pair 6 we're mixing G and H, so that's potassium iodide and lead 2 nitrate solution. Okay, see what happens with that one. And then the last one, you're going to take a chunk of zinc and you're going to put hydrochloric acid on and see what happens to it. So all of these reactions, with the exception of the first one, have very obvious visible changes. The first one is the only one that's not a visible change. Okay? So you'll have to possibly use some of your other senses to detect that one. Don't worry, I made it uber concentrated. You won't miss it, okay? Unless you're hard of smelling, like ridiculously hard of smelling, okay, to miss that one. All right, so that's what the lab is going to be tomorrow. It's just going to be doing those 7 pairs. It really shouldn't take us very long. Okay? It's just a matter of squirting the things together. So most of these are solutions. So they'll be in a little Erlenmeyer flask at the front, and there'll be eyedroppers in the flasks. So all you have to do is fill the eyedropper and take it back to your station and mix the 2 things together. Okay? Pretty straightforward. Once it's done, you take it to the waste bucket, rinse it off with the wash bottle, go back, do the next one. Okay, everyone follow me on that? Okay, so again, the lab itself takes very little time. We'll do the pre-lab and everything tomorrow with the variables and the hypothesis and walk you through all of that again. Okay, same as we did for the first one. Okay, and this time you don't have to design the procedure because as you can see, it's already here for you and you're just going to follow it. All right, and then when we're done, okay, we're going to be writing out the chemical reactions that occur. Okay, so predicting the products, balancing the reactions, same as we've been doing for the last little while. That's why I said we had to be good at doing prediction before we could do this lab, because the analysis is basically doing that. Okay, yeah, so that'll be the lab for tomorrow. Kind of questions on that? So we'll have a short quiz, just a couple of reactions to start class tomorrow. Then we'll do the pre-lab, then we'll go over and get the lab done. Be back over here, should have lots of time. Okay. That lab report's not due for a while. I can't remember what day I made it due for, but it'll pop up on Google Classroom tomorrow, okay? And it'll be all ready to go for you. Okay, questions there? Okay, I would like you guys finish off here those last ones. Okay, let's look at least 7 and 8 here. So on number 7, we have tetraphosphorus pentaoxide. So we have a molecular compound, okay, 4 phosphorus, okay, and 5 oxygens, and it breaks down. That means it's a decomposition reaction. So it's going to break down into phosphorus and oxygen, both of which are special elements. P is a 4, O is a 2. And we got to balance this thing. The phosphorus is already good, but the oxygens are not. So the lowest common multiple of 5 and 2 is 10. That ought to do it there. Okay. Questions on that one? Okay. And then for number 8, okay, we have tin. Tin is SN, and it reacts with beryllium nitride, okay, which is an ionic compound. This is a -3 and beryllium is a +2. Okay, so we're going to have Be3N2 for that one. All right, what kind of reaction is that? Single replacement, yeah. Okay, since tin is a metal, it's going to replace the beryllium. So the beryllium is going to end up by itself. Tin is going to wind up with nitrogen. When I drop and swap this, tin has more than one possible charge, and I don't know which one to use. So I should use, which one comes first? 4. All right, so I'm going to go with tin 4. Okay, so this will be a 4 plus. This will be a 3 minus. So when I drop and swap, SN3N4. Okay, and now I've got to balance this thing. 4 is the biggest number there, so I'm going to put a 2 here to balance that. That's going to give me 6 berylliums, so I need a 6 there, and there's 3 tin on that side. Now there's 3 tin on this side. So a bit of a tricky balance on that one. Okay. How many people have done 9 and 10? Okay, give you a couple more minutes, then we'll look at 9 and 10. Okay, expect that tomorrow's quiz is probably not going to be very long. 3, maybe 4 questions. The quiz I posted is going to be longer than that, so you get a little more practice, but tomorrow's quiz, just in the interest of time, will be shorter. And you can expect that probably you'll get, at least one that's a word problem, maybe 2, okay, and one that's maybe not. So expect that exactly what we're doing today is what you can expect for your quiz tomorrow. Okay, let's look at the last 2 here. So we got sodium bromide. So sodium is Na, okay, +1 with bromine, which is a -1. So we got NaBr. Reacts with lead 4 sulfide. So that's Pb with the 4+ charge with sulfur, which is a -2. So when I drop and swap that, I get 2 and 4. But I need to reduce that to 1 and 2. All right, what kind of reaction am I looking at there? Double replacement. Okay, so I'm going to swap the metals. That means that lead is now going to end up with bromine, and sodium is going to end up with sulfur. Okay, since they're both ionic compounds, they both require me to drop and swap them. All right, so we'll have Na2S, and this was a 4+, this was a 1-, so PbBr4 for that one. Okay, 4 is the biggest number, so we might as well balance that one first. If I put a 4 here, that balances the bromine, gives me 4 sodium. So I need to put a 2 here to get my 4 sodium. That gives me 2 sulfur, and there's already 2 sulfur here. 1 lead, 1 lead. Looks like it's all fixed. Okay. Questions on that one? Right. And then our last one, we got sulfur reacts with calcium. Did I forget anything? 8, yeah. Right. Sulfur is the most special of the special elements. Okay, what kind of reaction am I looking at? Synthesis reaction, okay. Did I do anything wrong? Yeah. What kind of compound does calcium and sulfur make? Makes an ionic compound. That is not an ionic compound. Oh, come on. So it's going to be CaS. All right, this is a -2, that's a +2, so that compound is okay the way I have it written. But I got 8 sulfur over here, so I'm going to need an 8 there and an 8 there. Okay. All right. Good work today, you guys. Make sure that you're clear on how this stuff works. If you're not, make sure you come in and see me for some help. Yeah, because when I drop and swap, I got to reduce down to the lowest terms, right? Because it would have been 2 and 4, but I reduced to 1.